The nation that destroys soil destroys itself. This powerful word by Franklin D. Roosevelt remind us that soil is not merely a natural resource, it is a very foundation of civilization. As beautifully expressed by Wendell Berry, soil is the great connector of lives, the source and destination of all. Indeed, soil sustains our crops, nourishes our food, supports biodiversity, regulates water, and acts as a silent guardian of our environment. When we care for our soil, we are caring for life itself. Jai Hind, a very warm welcome to day 6 of Society for Agricultural Advancement, Research, Training and Human Innovation, Knowledge Revolution in Agriculture, Nourishing Technology and Innovation 2026, our 33rd National Agricultural Training Program. On behalf of Agri SAARTHI team, it is my immense pleasure to welcome all participants and our esteemed resource person for today. I am Dr. Vijaya Kumari along with Nosina. We are from Agri SAARTHI team. We have been coordinating and guiding you through today's session. I also extend a warm and respectful welcome to our organizing director, Mr. Ajay Kasana sir, Chief Secretary of Agri SAARTHI KRANTI 2026. This initiatives, the vision of Mr. Ajay Kasana sir is envisioned to revolutionize agricultural education in India by creating a powerful knowledge platform that seamlessly blend sciences, sustainability, and hands-on practical learning. Once again, I would like to welcome you all for today's training program on caring for soil. In an era of climate change, land degradation, declining soil fertility, and increasing food demand, the importance of soil health has never been greater. Sustainable soil management is not just a scientific necessity, it is a moral responsibility. India has taken visionary steps through initiatives such as soil health card schemes, emphasizing balanced nutrient management and scientific soil care. Yet, policies alone are not enough. Awareness, education, and collective action are equally vital. Today's training program is a significant step in that direction. It aims to equip us with knowledge, practical insights, and innovative approaches to restore, conserve, and sustainably manage our precious soil resources. I am confident that the expert sessions lined up for today will enlighten us and inspire us to become true ambassador of soil conservation. It is a matter of immense pride and privilege to introduce our esteemed chief guest, Dr. Anil Kumar Singh, a towering personality in the field of natural resource management and soil science. Born on 29th April 1952 in Kanpur, India, Dr. Singh's academic journey reflects the brilliance and dedication from the very beginning. He received his early education at St. Joseph Academy and DAV College, Dehradun, followed by higher studies at the University of Lucknow. He earned his MSc with gold medal in 1972 and completed his PhD in 1977 from the prestigious institute IARI. Later, he was confirmed the honorary Doctor of Science, that is postdoc, in 2022 in recognition of his outstanding contribution to agricultural sciences. Dr. Singh enriched his global academic exposure as a DAAD fellow at the University of Hohenheim, received advanced training at the University of Arizona in on-farm water management and further strengthened his international expertise at the International Rice Research Institute. Professionally, his illustrations career began at IARI as a scientist in 1976, where he rose through the rank to become acting director. He served as a project director of the Water Technology Center and later as a deputy director general NRM at the Indian Council of Agricultural Research, New Delhi, guiding national research program on soil, water and climate resilience. He also served as a vice chancellor of Rajmata Vijayaraje Sindhi Krishi Vishwavidyalaya, where his visionary leadership strengthened agricultural education and research. Dr. Singh's contributions have been recognized with numerous prestigious awards, including the Soil Conservation Society of India Gold Medal, the Dr. C. Subramaniam Outstanding Teacher Award, the Fakhruddin Ali Ahmad Award by ICAR, the Bhuratna Award, and many distinguished memorial lectures and national honors. He has served as a president of several esteemed scientific bodies, including the Indian Society of Soil Science and the Indian Society of Agricultural Sciences, and has held key leadership role in national and international professional organizations. A fellow of multiple scientific academics and societies, Dr. Singh's research area include soil water nutrient plant atmosphere interaction, crop growth simulation modeling, irrigation water management, and integrated water management, areas that are central to sustainable soil and resource conservation. Sir, your lifelong dedication to advising advanced soil science and natural resource management has inspired generation of researchers, students, and farmers across the nation. Your presence today greatly elevates the significance of this training program. On behalf of the organizing committee and all participants, I extend our most respectful and heartfelt welcome to you. We are deeply honored to have you with us today and eagerly looking forward to your enlightening address. With great enthusiasm and hope, let us learn together, share together, and pledge together to protect the soil, the living skin of our planet. Now the stage is yours, sir. Sir, please, sir.
Okay. Can you hear me now?
Yes, sir.
I think there is some echo. Thank
sir.
you very much, Dr. Vijay, for the very kind welcome and introduction to the audience. And thank you very much for very detailed one. And it is my privilege to be talking to such a large audience on a topic which is very, very important. And I would like to share the screen if it's not an issue. My presentation is having 4 sections. The first will focus on why care for soil. Then I'd like to talk about these issues which are related to soil, and then how can we take care of the soil. And then, of course, maybe a few observations on how we can move forward. See, this World Soil Day on December 5, 2014 was decided. It is the birthday of late His Majesty Bhumibol Adulyadej Aliyevich he was king of Thailand, and he was after the FAO to celebrate this this particular day. So that is his birthday. Essentially, the purpose was to have a awareness raising platform at the global level. And so they started celebrating this from the international 2015. And in 2015, they declared the International Decade of Soils, 2015 to 2024. And then in Paris, there, all the countries in the world met together and sat down, and this is called the Paris Agreement, where they finalized the 2030 Sustainable Development Goals. The focus was on greenhouse gas emission reduction, because as we all know, that most of our problems now are related to increase in temperature, which is caused by increase in greenhouse gases. I hope you can hear me.
Yes, sir. Everything is working well. Please continue.
So in among the 17 goals which the United Nations have defined, which all countries have promised to fulfill by 2030, one very important was is land degradation neutrality, in which India has committed that we have to restore 26 million hectares of degraded lands by 2030. Earlier, this target was 21 million hectares, but in 2019, when we had this COP in New Delhi, our Honorable Prime Minister increased from 21 to 26 million hectares. Now, resigning the importance of soil, this particular government started a soil health card mission. It was launched on February 19, 2015 from Suratgarh, which is in Ganganagar district, Rajasthan. and that the target is 14 crores of soil health card in 3 years. That means each farm holding will have a card. So now you can imagine from 15, 16, 17, 18, 19, 20, 21, 22, 23. So there have been 3 cycles. So there are, and you can multiply by 14 crores. So that many soil health cards have been issued, and government has paid for sampling, for analysis, and for whatever, so that people make serious efforts to have the soil health card determined. December 5, 2022, the theme of the World Food Day was Soil, Where Food Begins. So this was to highlight the importance of maintaining healthy ecosystems and human well-being by addressing the challenge in soil management. Focus on increasing soil awareness and encouraging societies to improve soil health. And in this connection, the government is focusing on integrated nutrient management, organic farming, natural farming, basically the soil organic carbon, which is an indicator of soil health, how to increase that in the soil. And we all know that all life begins and ends from the soil. We have heard so many shlokas from our poets. It is the source of food, medicine that we take, and also filters our water, purifies it, among others. Unfortunately, most of us take soil for granted and assume it will always be around. So, and in December 2024, 5th December, the theme of the World Soil Day was caring for soils. And when we talk of caring for soils, it is when we talk of caring for soils, it is 3 aspects are there. One is measure, monitor, and manage. So we'll be talking about all these things in the lecture, all these why they are important. So why caring for soils matter? Soil is not just a growth medium. It is a living system that supports food production, water regulation, biodiversity, and also stabilize the climate. It is also true that 95% of our food depends directly or indirectly on soils. And we also know, all basic students of agriculture, that only forming 1 centimeter of topsoil can take hundreds of years. But we can lose that in maybe sometimes because of heavy rains, soil erosion, even maybe in hours, days. But certainly, if we don't take care of it, you can lose that in 1 season. The harsh truth is that globally, about 1/3 of soils are degraded due to erosion, salinization, compaction, acidification, and contamination. If we take India specifically, 30% of land with major impacts on productivity and farmer livelihoods is degraded. So it affects not only productivity, but also livelihoods. And so the core message, that is why caring for soil matters, is because it is essential for food security, ecosystem resilience, and also intergenerational equity. What does it really imply? It means that you are maintaining and enhancing soil functions, not just maximizing the short-term yields. That means it is just not only the crop that is harvested, but there are other functions also. And these functions are, for example, productivity. We are all familiar with that. We focus all our management on productivity, which through soils, the nutrients are provided to the plant. The roots are supported by soil. When it comes to regulation, it is water infiltration. We apply water to the soil, and that goes into the plant, and then the plant takes it up. The soil stores this water in addition to the filtration. Filtration means purifying the soil, the water. And then also it is a habitat for soil biodiversity. As you all know, it is the microbial population in the soil which actually decomposes whatever we do and makes it available to the plant. And the most important, which is now, is the carbon storage. That means the climate change mitigation. They say that if you can increase organic carbon content in the soil, that is sequester carbon, you can probably modify, moderate the effects of climate change. And in addition to that, we all know that soil, we call it Mother Earth, Dharti Mata, and it have many unmemorable services also. So basically, it means that the focus shifts from soil exploitation to soil stewardship. Now, what does soil stewardship means? It means that you are supposed to manage soils in a very responsible manner so that it is we leave something for the future generation. That means we should consider that it is something which we have not inherited from our ancestors. We have borrowed it from children. So caring for soil is also said caring for life itself. So this is the importance which we always assign to soil. Now, just to make some figures, that it is said that globally more than 2 billion hectares of previously productive land is degraded. So you can understand this situation. The estimates say that over 70% of natural ecosystems have been transformed, and this could rise to 90% by 2050. Considering the globally by 2030, food production will require an additional 300 million hectares. That means if we are not able to increase the productivity, we need that much land. It is also said by 2030, the fashion industry is predicted to use 35% more land. That means the requirement would be around 150 million. When we talk of fashion industry, most of the cosmetics, everything, the clothes, textiles, cosmetics are all derived from plants which need space to. And India, with only 2.4% of land and a population of 18%, plus 15% of livestock, so faces a severe problem land degradation, which means soil becoming unfit for cultivation or reducing productivity. That is why many people have been highlighting this problem. Soil resource is something which is finite and almost non-renewable. As I said, it takes several hundred years for a soil to form. So science in 2004 said that soil is the final frontier. Schmidt and Keith in 2010 said that soil is the last frontier or the ultimate frontier. So which means that you have to take care of it. In fact, it was said by David Pimentel that soil erosion is second only to population growth as the biggest environmental problem the world faces. Yet, the problem which is growing even more critical is being ignored because who gets excited about dirt? It's very, very obvious. And as I mentioned about the soil, it takes just seconds through a heavy rainfall to wash away the soil, which takes so many years to form. And Franklin D. Roosevelt, former U.S. president, said the nation that destroys its soil destroys itself. So that is the importance. Why you need to care for this soil? Because soil health, we are always talking about human health, animal health, but soil health and productivity are related. Because healthy soils are essential for agriculture productivity. We all know 70 nutrients are required if you really want to maximize production. We also talk of the malnutrition that is happening in the country because the nutrients are not, micronutrients in particular, are not available. And that is because the soil is poor in micronutrients. I'll be giving some data on that. And that is magnified as we feed on the plants and the animals feed on the plants which we consume. And so those deficiencies increase. And it's also a habitat for beneficial microorganisms that support plant growth. Many of the microorganisms are known to really support the plant during stress. Biodiversity support, as I said, microorganisms, bacteria, fungi, insects, earthworms, they all contribute to the ecosystem health and biodiversity. You all know that when we talk of organic farming or natural farming, the presence of earthworms is an indicator that everything is fine with the ecosystem. Water regulation is very important because not only that the water passes through the soil and goes to the roots, but it also cleans the water and also retains water once you irrigate so that the water is available to the plant subsequently. Because it is able to retain water, it can reduce the impact of flooding and also erosion. as I said, the greenhouse gases means we are actually having a lot of carbon dioxide in the atmosphere. If you look at now I think it's around 426 or something ppm, that was last year's data, which shows that carbon dioxide is increasing. And when increasing carbon dioxide means that the temperature is going to increase. So if you remove carbon and sequester it, then you're able to moderate the effect of climate change. Nutrient cycling, you all know that there are soils, it is through soils that all the nutrients are made available. And when we say organic matter or natural farming, it is those nutrients which are which are there in the soil, which are converted by the microorganisms into available form. Obviously, if the soil is healthy and your productivity is good, it ensures food security. And we all know that India is the only current country which has a National Food Security Act, which means that to provide all those, we are providing 80 crores food free for the last so many years. We have to produce our food that is homegrown food. We have to produce our own food. We cannot go and buy wheat or rice from the international market, because the moment India goes, 1 million ton of wheat or 1 million ton of rice is nothing compared to what we produce. But if we go to the market and say, okay, we want to import or buy one, immediately prices will shoot up. And then comes the importance of monitoring and measuring, which means regular assessment of soil health. And this allows the identification of issues such as erosion, nutrient depletion, and contamination. And that is why the government started the soil health mission. Then it's not only just the addition of chemicals. We say that we must look at it, integrated management of soil. So crop rotation, cover cropping, organic amendments, and so that we are able to increase the soil resilience. And obviously, to do all these things, we need to have a policy in place. We have a promoting soil health policy there, and awareness. And that is why we have this World Soil Day, and we try to highlight the awareness, the importance of soil on that day. And as I said, though sustainable goals are there, there is only one goal. If you look at this goal, SDG, which is for land, but the soil is essential for multiple SDGs, and I'll be showing you some of them. And they relate to hunger, health, clean water, and climate action. So it's not only one among the 17, but it affects about 7, 8 other. So these are when this Paris Agreement took place in 2015, it was very clear that it's not only to end poverty, it is also to protect planet and improve lives of all of us who are living on this planet. If you see only the goal number 15, that is life on land, that deals directly with soil. But it is not that. If you look, there are so many things which are associated. Number one itself, no poverty, because we have to increase the livelihood, we have to increase the production or the productivity. So obviously, soil has to be the focus of it. Zero hunger means you have to produce more so that we can feed the population. The third one is good health and well-being, which means you have to produce nutritious crops and reduce malnutrition. As I said, micronutrient deficiency is very highly prevalent, and I'll show you some figures for that. And because the soil acts as a filter, then clean water is also something. It reduces groundwater pollution. And then the 12th one is responsible consumption and production. That means waste reduction and sustainable production. Again, soil. And then, of course, climate action. As I said, the soil organic carbon storage has to be done. Otherwise, we will not be able to reduce the impact of these. And then, even for those where we talk of aquaculture, the soil at the bottom is also important so that we can prevent eutrophication. And of course, number 15 is soil itself. So, improved soil biodiversity is very, very important. So why all these things are important? Because we have certain commitments at the national level. We all know food and nutrition security. I've talked about it. We also know that we have to increase the income and job opportunities, all of us. We also know we have to reduce environmental degradation. Otherwise, it's going to be a serious issue. And then, of course, improvement of liability and whatever we do, it has to sustain because we are the most populous nation and our population is going to keep on increasing, maybe stabilize around 2070. Then there are certain international commitments by 2030. One is reduce emissions intensity by 45%. Second is, of course, draw 50% of energy from renewable sources. And we also insist that the irrigation, for example, should be done through solar pumps. That will reduce the fossil fuel burning. And raise non-fossil fuel based energy capacity to 500 gigawatts. To meet these targets, we have to cut the carbon emission by 1 billion tons. And I also mentioned about the land degradation neutrality. We all know that by 2070, India has committed that it will be having net zero emission. That means carbon neutrality. Whatever we are emitting, we are going to sequester. Earlier, the ethanol blending of petrol by 20% was the target was set for 2030. Now it is set by 2025. So now you have to produce more ethanol, which means you have to some part of the crop, some part of the land is going to be earmarked for production of ethanol. That means the crop that is going to be grown. So a lot of pressure will be there. So the question is how Indian agriculture can contribute to fulfill these commitments and also become climate resilient and carbon neutral. So you have to increase the productivity to meet the population demand, the other demands that are there, and also see that you become carbon neutral. Just to give you an idea that what is the greenhouse gas climate change in agriculture. So this just shows that agriculture now has become only 14%, right? If you look at the global level, now India's. But if you look at the breakup of India, you can see that 79% is carbon dioxide, methane, and nitrous oxide 5%, and the rest is others. Now let's see if we can break it up what happens. Now, if you look at the different economic sectors, so agriculture is 14% out of the total. Energy, of course, is the maximum. That's why we are saying we should have to shift from go to renewable energy. And if you look at the subsectors of agriculture, see, when this whole methane business started, carbon greenhouse gas, rice was blamed that it is emitting methane and that is causing all the problems to everybody. But now, if you look at it, it is the rice fields is 17%, but agricultural soils is now contributing 19%. So that means the contribution towards greenhouse gases from the soil has increased, plus crop residues and manure management. Now, the difference is that when we talk of rice, it is methane. When we talk of agriculture soil, it is nitrous oxide. And nitrous oxide is having 300 times more residential tank compared to carbon dioxide. So, when we come to agriculture, these are the critical inputs we have heard about, that you should have seeds, that is high yielding varieties. Water was the one important thing that you have improved the irrigation structure, supply water, because if water is available, farmer will tend to buy better varieties, buy fertilizers. And of course, as you all know, green revolution fertilizers played a very key role. And then the fourth pillar that I always say is the plant protection, that is herbicides, pesticides, because they also cause quite a loss as far as production is concerned. And then tillage was also considered important. You must properly till the soil so that the plant grows comfortably. And of course, we need labor for all these activities. The shift now, what we call as the climate resilient or climate smart agriculture, is that now we want to have varieties which are more input efficient. So they produce more from less. And they are also tolerant to abiotic and biotic stresses. And then also must be biofortified. So that take care of malnutrition. In case of water, now we are very clear it is water productivity. That is how you enhance income per unit of quantum of water that you use. So just we are not talking water use, it is water productivity now. And increase the fertilizers. As I said, we have to think in efficiency because fertilizers are responsible. I'll be showing some data on that for, as I said, nitrous oxide emission. And we also want to reduce the herbicides, pesticides, because we want to minimize the impact on the environment. Tillage, earlier when we were, we all know in the villages you're told that you have to till the soil, maximum tillage so that the soil is friable and all that. Now the purpose is that you have to minimize tillage so that the whatever carbon is locked in the soil is not released. And of course, labor is becoming a problem. So you have to maximize the labor productivity, which means you have to focus on mechanization. And only then this evergreen revolution is going to be possible. Now, some economists have estimated that if you really want to feed this population of 1.68 or 1.7 billion by 2050, the land productivity has to increase 4 times, the water productivity by 3 times, labor productivity by 6 times. Means you have to probably go on more on mechanization, automation, using modern tools because labor is becoming a problem. And all this has to be done with low emission technology because we want to reduce the impact on the greenhouse gas emission. We also know that in case of India, the net cultivated area has been around 141, 142 since 1970. And there is very little scope for area expansion. So you have to intensify the agricultural activities on that same piece of land. And we also know that a lot of strain has been put on the natural resources, whether it's soil, water, they are being degraded. The land is being also converted because you all know because of urbanization, a lot of productive land is being lost to urban sector, to the industrial sector. And this not only damages, it makes the whole agriculture production system unsustainable, reduces production and affects the ecosystems and biodiversity. So what is the option? The option is that you have to go in for modern tools and techniques like biotechnology. I club all these things under precision farming, and I'll elaborate a little bit on what I mean by that. Now you just look at the area under degradation. Why I'm showing this figure is because we are supposed to be restoring 26 million hectares by 2030. That is our commitment. But the latest report by the Space Application Center shows that in the 2003-5 to 2018-19, the area under degradation has increased by almost more than 3 million hectares. Okay. So this is a very disturbing, as I said, about 30% is now degraded. 3 million hectares makes a big impact when it comes to productivity. Now, when we look at the degradation levels, you can see that in those three, water erosion has increased, vegetation degradation has also increased, only wind erosion has reduced slightly, but otherwise waterlogging, frost shattering, mass movement because of settlement of soil, except for the salinity part, most of these degradation levels have increased. So this is a point of worry why we are insisting and talking so much about the soil caring. If you that was trying to show you the causes. Now, if you look at the type of land use, so the agriculture unirrigated, we have about maybe 45% of our net cultivated area which is rain-fed. So there the degraded area is 38%. The irrigated area, it is only 8% because we generally level the field and take care of all those things. So in the forest area, it's about 22%. Scrubland, it is 14%. So this is the situation. This is how we have to tackle because irrigated and unirrigated area, which is almost 142 million hectares, that is again about 30% degraded. So we have to take measures how we grow our crops. So this is just sort of highlighting the figures I've shown. What it shows is that in about grassland area, grassland areas are supposed to be also sequestering carbon and providing stability to the environment. We have lost 5.65 million hectares. Desertification has increased in 26 out of 29 states. 80% of degraded land lies only in 9 states. Now, this has happened in spite of so many steps taken by the government. I mean, there are all programs which I mentioned, which government has taken at various times, starting from 1974, in trying to improve the soil. But this is the latest situation. And the figures that I mentioned were by the Desertification Land Degradation Atlas of India, which was issued by ISRO in 2021. So these are different states where the degradation is taking place. As I said, 80% is there. 9 states are the ones which are the mostly, that is Rajasthan, Maharashtra, Gujarat, Ladakh, Karnataka, Jharkhand, Odisha, Madhya Pradesh, Telangana. They almost constitute 80% of the degraded lands. Irrigated lands are also being degraded because, for example, I have listed Punjab, but when you are growing rice and water, you are putting a lot of fertilizers, putting a lot of water in the land, the quality of soil is decreasing every year. So that is why it shows that in Punjab it is degraded so much. What is the economic loss because of this? So you can see that it is 3.17 lakh crores, which is almost 2.5% of the country's GDP. And it affects at the global level 3.2 billion people. And if you look at the biodiversity and the ecosystem services, 10% of the annual global loss product is in these terms. And it is estimated that by 2050, land degraded climate change can lead to reducing crop yield by 10% globally and up to 50% in certain regions, besides causing 50 to 70 million people to migrate. This is going to be a huge impact. This is one slide which I like to show, because when we talk of soil, two things are there in this figure. One is the per capita water storage. Now, if you see India, 225, this is China, 1,111. So, same level of population, but the per capita water storage is 1/5 in India. That is number one. And one of the factors is, you see this one, that we are losing the capacity of our reservoirs at the rate of 1.95 billion cubic meters, right? So this is, and why it is, because we are not treating our catchment areas from where which the water flows to these dams and reservoirs. If you have to create this much of volume or the space in our reservoir, it is going to cost 20 billion. So this is because we are not taking care of our catchment areas. Silting is reducing the capacity of our reservoirs. And I said we are already at a very critical stage when it comes to the availability of water, if in case something happens and monsoon fails. Another factor which is very important, we all hear about, is crop residue recycling. Every winter you hear about crop burning. And it's not only that you are burning those crops, we are losing a lot of nutrients. And it was estimated now, of course, the government is taking very strict action on burning. So it is reducing, but it's still not totally stopped. And if you take care of this crop, you have 100 million tons of carbon source available to the fields. In case of horticulture, we all know these perishable goods, the wastage is all even more comparatively. And even in rainfed crops now, burning is increasing. And it is surprising that when we hear it's winters because of the paddy straw, but it is the wheat straw which is also being burned. And I've seen it myself in Maharashtra in particular, that in April they are burning the wheat straw. It can be converted to biochar, which can improve the fertilizer use efficiency also and reduce the load on the chemical fertilizers. And this is just the sort of loss. That means each ton of crop residue means you are losing 5.5 kg of nitrogen, 1.2 kg of sulfur, phosphorus, and potash plus organic carbon, which is very important. So, and it's all this is going to be, if you could recycle these residues, it is possible to and improve, let us say, the nitrogen use efficiency by 10%. So if you have 30 million hectares of wheat, you can imagine so much amount of 900 crores can be saved. In case of rice, it is even more, because we add a lot of more fertilizers in, and the area is much larger. It is now, in fact, crossed 50 million hectares. So the amount of money that can be saved is much larger compared to wheat. So these are things where we can easily do this part. The other important factor is, which many of us may have observed, when you travel along the highways. India is the second largest producer of brick kilns. right? And we have to provide home, as you know, government program is there that we have to provide home to every person, every family in our country. So from where will the bricks come? There are many options. For example, fly ash is done, but then there is fly ash is produced somewhere. To transport it to where the construction is going on is going to be a big issue. So it's not only that we are adding teragrams 20.48, 22.46 through this firing process. So it is also, reducing the economic yield by 60 to 90%, because when the farmers go back and try to use that soil or that land which was there, so that needs a lot more inputs, because otherwise you suffer from 60 to 90%. And we have already lost about 0.8 million hectares, and it is estimated around 40,000 hectares every year are being lost because of brick kilns. And these brick kiln industries are actually utilizing the most fertile layer of the soil. And as you know, each centimeter takes several hundred years to build up. And this is what we are losing for construction. Okay. Now, coming to what is the current status of soil? You can see the deficiencies. We all know nitrogen, phosphorus. We are very much aware. These are our major nutrients, and we all talk of NPK whenever we talk of the soil management. But there are secondary nutrients like sulfur, 41%. Look at the micronutrients: zinc, boron, iron, molybdenum, manganese. They appear to be very small quantities, but they are increasing because they are not being added to the soil. Now, for example, magnesium deficiencies have been reported from Kerala. 80% samples have proved that there is magnesium deficiency, which was never there earlier. Manganese deficiency was not there in wheat crop, which is now coming to the state recommendation. And I think we are all aware of these are textbook information. Nutrients deficiency in soil application, nitrogen 30 to 50, phosphorus, potassium, sulfur. Micronutrients, the efficiency is less than 5%. Given the reasons for that, immobilization, utilization, denitrification, leaching, fixation, and immobilization, and so there is a lot of scope when you look at the efficiencies, except for potassium, which is 70 to 80% because it's fixed and it isn't lost to leaching or something. But otherwise, the other efficiencies are very, very low. It's not that we have not been working on these things. There are so many experiments done, technology. For example, if I just like to say about neem-coated urea, neem-coated urea as a technology was developed by ICAR long time back, several decades back. But nobody bothered about it. Only now when they realize that the fertilizer subsidy is there and the fertilizer is being diverted to some other sectors, that they thought that if if you use neem-coated urea, probably it will help us. It does help because it releases nitrogen slowly. It also has a less environmental impact. It benefits, but nobody bothered about this technology, and that is why, even if you remember, a normal urea bag is 50 kg. So neem coated urea, they said 45, because farmers will always use a bag of urea as a recommendation. They are not bothered about the weight. Of course, now you have nano coated urea, nano coated DAP, and sulfur coated. So many other products are coming up, basically because, and you can see, you can easily increase the efficiency of nitrogen 15 to 20%, even just by application. And you all know, if we go to the farmer's field, these fertilizers are being broadcasted, wherever you go, except for those who are using drip system with fertigation. And we all know that that is the most inefficient way of applying fertilizers. But you are doing it. One of the reasons that it's very, very cheap, government is providing is supporting this. A lot of things have been done otherwise. A lot of work has been done on the fertilizers. Control release formulation. They call it smart fertilizers. So they will release the nutrients as per the required. There are ways in reducing the solubility so that micronutrients are available again easily. You can also increase the efficiency. Nano is one of the options. There are many chemicals which are hydrogels are there, which you can put on the fertilizer, and then that is released slowly. There are permeable, but these are of course expensive ones, and the because they are expensive, they are not being popularized because there's no incentive for anybody to really save fertilizers. Now, this is one very simple example. It is not related to the fertilizer part, but laser leveling of the field. LL here means laser leveling. Laser leveling is generally adopted so that the field is leveled and your water efficiency, water application efficiency improves. But the greatest benefit, in addition to water efficiency, is that you can improve the agronomic efficiency of nitrogen, phosphorus, and potash, almost double it by just levels. This is why I wanted to show you on this particular slide that it is possible. So, in fact, if you increase the water use efficiency, the nutrient use efficiency also increases. And that is why when we use drip irrigation and fertigation, that our efficiency also improves. Now let's talk about why measuring is important. Some of you might recall that when initially India was blamed for methane emission from the rice fields because India has the largest share in rice. China also had a lot of rice, but then the values which were used by for those who scientists who were there was around this range, 37.5. Then we in the country thought that let us try to diagnose because most of you who are chemistry know that methane emission occurs when the redox potential values are very low, that is minus 350, 400. For that, you need to flood the soil for several weeks, before it reaches that redox potential. It doesn't happen under Indian conditions except for waterlogged soils, that is rain-fed lowland, or deep water rice. Otherwise, the rest of the rices, and in India we know, for example, if you go to Punjab and Haryana, the soils are sandy soils, the water doesn't stagnate, so they irrigate very frequently. So then, and we started all these measurements when I was at ICAR, and you can see that finally, the values for which is now internationally accepted is 3.3, 3.5, which is less than 10%. Okay, so it was more than 10 folds higher, almost 12 times higher, 10 to 12 times higher, which was being, and that is why we were blamed. So this is why the measuring becomes very important. And you can see here, when we say of soil and water management, see, these are about different crops. You see rice, lowland rice does emit a lot of emission. But if you look at the upland rice, a very sizable area, you see the difference in the greenhouse emission there. Of course, sugarcane, we add more water, but other crops we don't. So you have very little emission of greenhouse gas emission. So basically, if you can manage, and now all know that in case of rice, a lot of focus is on the dry seeded rice, and you don't have to. In fact, we did recommend long time back that rice doesn't need standing water. If you can keep the soil saturated, rice will yield. It does affect the weed population. So weed management occurs through flooding the soil, not really anything on the productivity of rice. Okay, so this is one thing. Now there is a lot of problem of arsenic. In Bangladesh, West Bengal, it is now moving. I would say westwards, coming to Punjab and all that. It has already reached Chandigarh. It has reached UP. Why? Because you are drawing excessive groundwater from the deep water table. So it creates the conditions in which arsenic becomes soluble. It comes to the water. But when was this recognized? When the human health was affected and the symptoms could be seen in humans. Then they realized that it is because of arsenic. They could see it in the animals, and this arsenic came from the rice which was produced because of this excess pumping. Again, it is soil and water management which is causing these things, not really the crop as such. Okay, so this is what I wanted to highlight was management is very, very critical in many of these things. Now, this is just to show you that if you apply nitrogen only once, this is sort of losses you have. But if you can apply in installments, this is the efficiency, and you can see that. So a lot of inefficiencies which are associated with this basal application, and one time or two or three times, they can cause a lot of losses to nitrogen. And this is just one example. This was not done in 1977, where they had a conventional system and an improved system. What was the improved one? The conventional was this one, where they had natural rainfall, daily irrigation, and then they had a tensiometer. Tensiometer, most of you must be knowing, gives you the soil water tension. So then soil water tension also is the force by which water is being held by the soil. So if you can schedule your irrigation, your water use efficiency increases. So you can see in the conventional system, the natural rainfall, daily irrigation. Daily irrigation means now we can do it by drip, but at the time for this experimental purpose they did it. You can see the yield and the water use efficiency. And when it was tensiometer scheduled, right? The water here it was 50 centimeters given through irrigation, and this was 26 centimeters. So obviously, the water use efficiency increased. And if you could, this was with the water management part. Now, if you apply the same fertilizer, this was the same amount of fertilizer. Here it was 338 nitrogen, I'm giving, for example, and here it was in 3, 112, 19, 20. So in this case, what they did was they have just given in so 5%, 10%, 20%, something that what we do in drip fertigation. And this impacted, see, the amount of water use efficiency. It also gave better yield under all conditions. Right? So this is the important thing is that the plant should be given fertilizers when it requires, not when it's convenient to you to apply. Right? This is a very simple example that if you don't have to apply on the, normally we always apply fertilizers before the sowing is of the crop. Here you can see if you can delay it by 7 to 14 days, right? Basal, it is nitrogen is 50%. It can go as high as 60%. That means 10% of the nutrient use efficiency can be utilized, can be obtained by delaying this. Because what happens is initially, and this is an experiment of maize, which is very fast growing, initially there is enough nitrogen in the soil for the plant to grow. And in 2 weeks, then when by the time you apply it next time, the roots have come up, then you have fertilization, and then the efficiency increases. A very simple modification. And this is also when to apply urea. Okay, you can see the loss if you apply before irrigation, right? Just nothing doing much except apply urea before irrigation. You can see these are the recovery of before irrigation. You can see the yield is higher, and these are the losses. Excuse me. So again, a very simple management option which can make which doesn't require any high-tech solution, but is there. Now, this is one example which I like to give from Bangladesh. What happened when the prices shot up? In government of India, of course, buffered was a buffer, and it did not let the prices of urea increase. But there, the government said we don't have money, so you have to increase the price. You have to pay for whatever it is. So at that time, they devised this urea deep placement technology using briquettes. And then they had an adapter because in Bangladesh rice is grown almost many times, 2 or 3 times in the year, most of the places. So how to design? So designed a manual one of deep placement of urea, and then they also had a mechanical version of this. This was a manual one, and there's also a motorized version. Now, this is just to give you what happened. Earlier, to minimize losses of urea, they used to apply in 3 splits. 40% was utilized by plant, 60% lost, as I showed you, right? They are nitrogen efficiency. Now, they said urea, if you give in form of super granules, it is superior to the granular common urea which is available. And this is applied only once, 5 to 7 days after planting. As I showed you, the plant doesn't require the initial stages if you can delay it. So instead of a normal dose of 247 kg per hectare, only 160 kg per hectare was needed. That means 35% less. And the rice increased by 20%. So, plus the benefit to the environment. So this simple intervention made such a big difference. The farmer had to pay about 40% price more, but he was able to compensate for it. Same things can be done in India, in West Bengal, in Orissa, in you can say Bihar, where we have such things. But even today, as I said earlier, we are just applying broadcasting fertilizers. Now, this is just to show you what happens. I mentioned in one of the slides that you need to increase the efficiency of 3 to 4 times. So if you can apply fertilizer through fertigation, that means through a drip system. I've shown the figures here. In case of nitrogen, if you use in soil, it is 30 to 40%. By fertigation, it goes up to 95%. Phosphorus from 20 to 45. Potassium 60 to 80. So these are the efficiency levels which can be attained. Purpose of showing this slide is it is possible, and government is giving a lot of push on drip irrigation and this micro irrigation, both of this drip and sprinkler, because they know it's not only the water use efficiency, but the fertilizer use efficiency also is improved considerably. So, yeah. Okay. The other advantage I mentioned about was drip irrigation. Now, a lot of work has been done on to grow rice with drip irrigation. Of course, it seems very difficult to believe, but it is possible. It has been done. And this is a study which has been done not in India, somewhere else, where they showed, and it has been confirmed in India also. Now, we have many studies now. Jan irrigation is popularizing this drip irrigation for rice through systems. You can see the difference. The soil has the same level of arsenic, sorry, 5.7, 5.8. This is flooded system, and this is through drip. You can see the arsenic concentration. Same soil, if it is through drip, there's hardly any accumulation. Only there is some accumulation in the roots, which is much less compared to the roots when you are using flood irrigation. Otherwise, you can see the arsenic accumulation everywhere, but not detected in the plant parts. So this makes another advantage why water management helps in taking care of the arsenic contamination or whatever is happening in those areas where they are using excess water for rice. Now, this is one table I like to show. You see, this is the figure that is being generally quoted. When you talk about fertilizer, the Punjab is adding 240, Haryana 2606, Uttar Pradesh 200, and all that. This is worked out, which is recommended. For example, in India says it is 138.10, right? But this is done on the gross area, right? That means if you are going 2 crops on the same area, you add more fertilizer. And if you take on the net cropped area, for example, Punjab, Haryana, even Bihar has a lot of fertilizer, 225 kg per hectare. As you can imagine, of course, this time it is slightly less than Haryana. So, which means that you are in fact adding that much fertilizers on that same piece of land, not 241, but 458. Assuming 60% of this is nitrogen and 30% or 40%, 50% wastage is there, you can see how much nitrogen is going into the environment as nitric oxide or as nitrate in the groundwater. So this is why this becomes important, and why we must improve the fertilizer nutrient use efficiency with all possible ways we can. This was just to add. And what implication it has is, see, this is the fertilizer subsidy. These are 1.7 trillion rupees, okay? These are all trillion rupees. This was 123-24. You can see 24-25, 25-26, 26-27. So these are the values which are being given by the government is paying for fertilizer that is farmers are using, and that is why we are having these environmental issues. The said nitric oxide is one of them. And that's why the government started this PM Pranam, that is PM Program for Restoration, Awareness, Nourishment and Amelioration of Mother Earth. And it is trying to promote alternate nutrients for agriculture, and that is why we have a lot of focus on organic farming or natural farming. And these are the decisions at the national level. Why I'm mentioning this is that government wants that we should be able to, uh, optimize or effective use fertilizer more efficiently. Soil health card, the basis of that you start giving fertilizer as per the requirement. And the soil health card takes care of all the micronutrients also. So it takes care of both the soil health as well as your human health, animal health. Neem coated urea, nano DAP, now we have sulfur coated. All these things, this technology was developed much earlier, but now is being promoted by the government. I mentioned about the PNAM scheme. In this, actually, if the state is able to reduce the fertilizer consumption, whatever is saved as subsidy is given to the farmer and to the state. So they benefit. So farmers also get some incentive because of that. The insurance scheme of farmers is also there. So if you are able to, you know, quantify your yield, you are able to get it, because this is very important, because earlier, because of natural calamities, and there was a problem that yields are, now earlier it was, only because of flooding or irrigation. Now, even germination, any waterlogging, in these, all these are covered in this scheme. So through the entire, so all this is farmer gets better. Of course, irrigation water availability, I mentioned about drip irrigation and हर खेत को पानी. What it means is that if a farmer is short of water, he is willing to invest in fertilizers and in better seeds. Agroforestry mission is there so that you are able to increase soil carbon. Carbon sequestration is more permanent in an agroforestry system than a pure crop system. And that is where the integrated farming system is where you try to minimize the external footprints, try to recycle nutrients from the within the system so that you reduce the chemical use. So these are the programs. There again, I would not like to give in details, but zero tillage, laser land leveling, direct seeding rice, I think many governments, Punjab government, Haryana government, and many other governments are giving, even UP is giving, because this saves water, and then so they are there. Raised bed planting, in fact, all crops can be used in raised bed planting. Raised bed planting means you about say about 20% of water and 20% increase in the yield. And the advantage is that if it rains too much, these furrows act as drains. And all crops can be grown through raised bed. So this is it's always been maybe you have to adjust the raised bed depending upon the spacing of the crop, but it's possible. Leaf color chart was very popularized by and is being staged because it is able to reduce 10 to 20 kg of nitrogen if you give based on what the plant shows. I have already talked about residue management. I've talked about drip sprinkler irrigation in terms of efficiencies. Now, so this gives the benefits of the resource conservation technologies, productivity gain, profitability gain, water savings, and the mitigation of greenhouse gases. Why we need to adopt this technology, and if we take the whole package as such, the climate smart agriculture, as I mentioned, you can have a productivity gain of 1 ton per hectare. That is the gain, and profitability would increase by 15,000. Water savings be around 20%, and the mitigation would be up to the level of 3 tons or 2.9 tons per carbon dioxide. And these can now be converted into carbon credits, and you can probably get some money for that. So now to talk about why I mentioned about precision farming. Now just let us see about this. What is field variability? There are three variability. One is when you look at the soil, and you find variation in the yield, it is the soil properties vary in terms of physical, chemical, and biological. Physical properties like soil texture is there, bug density is there, infiltration rate is there. Chemical means nutrient content, pH. And biological means the microbial population, and which is there, so, and diseases and pests. So these come under those variability which occurs in the field. Then there is temporal variability. That means the changes that occur in a particular production system year-wise or during the growth period. Then the question is that what the third is the predictive variability. That means you have done all best possible, management practices. Even then you don't get yield what is expected. So what could be the reasons? Then you find out this what is this disturbance caused by? Whether it is between the predicted and actual yield, is it because of pests, disease, weeds, weather, or then you tend to identify that factor and then take corrective measures. When this precision farming started, that was in the US, where they have large fields. And they started basically with the fertilizer application. But now it is possible that you can do it at micro level, that Indian farming under Indian conditions. And I'll just tell you how it is possible. Now, just I'm giving one sample of what happens. This is one experimental field taken from IRI, where we assumed that this field is uniform for our experiment. What treatments you are doing. But you see the variability. It is from 150 to 213, right? So all under low nitrogen, but this is the variability. Okay, this is for phosphorus, 28.4 to 68.7. And this is for potassium. You can see variability is 171. Now, what we are doing is we are taking the average of all these values, take samples from 577 places, and then we work out the average, and then we give a. Now, that average value may not be occurring anywhere in the field, or maybe at one or two spots, right? I'll give an example here. This is an average soil test value for pH, P2O5 and K2H. Some study, they had 7 locations, and this is the difference from mean of the measured parameters. And this, I'll make it clear. Okay, so that pH value, this is the actual value of the sample, right? And the measured values of those 7 spots. What was done was the average was taken of all these 7 places. Now, these are the average values. And on this basis of average value, the fertilizer recommendation was given, right? And this also shows what is the mean value difference from each of these. So difference from mean for P2O5 and K2. Now, what happens is, you see here. Now, we gave, the farmer gave this fertilizer application, right? This is a large area, so many kilograms of phosphate everywhere. But see, this is the variation. 4%, 50%, 34%. This is plus and this is minus. Now, what does this, and then this is the corrected value. Okay. And this gives the, but you find that total, there's only difference of 118 kg from almost 15.9 and 16.0. So the total amount of fertilizer was not much, probably in terms of rupees. But see, you are in areas 4%, 50%, 34%, you are actually adding more than they require. So you are wasting your fertilizer because they are already having more value. But in these places, it is minus. So here you're giving just the those values. So what this happens is that means you are under applying fertilizer there. So you have two things. One is this fertilizer, this is not working here. Sorry, but this was showing. This was a figure which shows that among the fields where you are having surplus, where you are having deficit. So as I said, those values indicate that you are, except for one point where they had the average value, either you're over or under. Over means you are wasting your fertilizer, money spent on fertilizer. Under means you're affecting the productivity. Now this gives you a summary. As I am just mentioning the water smart technologies because the current level of technologies are there, they can improve the, because I also mentioned the what is efficiency that is needed, productivity. So these efficiencies are possible. And 10 to 20% are very easily achievable with the current level of technologies. And if you can do it in large scale, of course, it will make a big difference. Government is already pushing a lot of precision farming. Now, why do we need precision agriculture? Many reasons. One is we have irrigation commands which are spread over large areas, right? And we all know that the irrigation, the efficiencies are very low. There are, for tail end farmers do not get water. The head reach farmers are able to get more water. So there's distribution effect. So you can monitor these. Why should it happen? One should get more water, the other should get less water. Watersheds, you all know, are very not easily accessible all through, but you need to know what are the variabilities. So all this leads into low input efficiencies, degradation of natural resources, and of course contribution to global warming. So farming has to be technically based for its variability. I have given an example of variability as far as when it comes to nutrients. And of course, because of climate impact, you need to apply more water, more nutrients, and you come across more and newer pest and disease, so your cost of cultivation increases. Now, what is precision farming? Now, it was initially called satellite farming or site-specific crop management because this Pierre Roberts is the one who is called the father of precision farming, and he termed it as soil-specific crop management. Hmm. This was done in 1982. Now, in US, there are huge farms. So he tried to find out how to reduce the efficiency and is it possible to apply fertilizer as per the site requirement, as I showed you the variation. So, and at that time, of course, a satellite was there and a GPS was there, so he was able to, and large farms, so he could manage to know and but through GPS what is the fertilizer at each spot and then find the variation. And that is why it was called the soil specific crop management. And now, of course, we know that it's not only fertilizer, we can use it for all other inputs. So, so basically, focus is managing inter and intra-field variability, both spatial and temporally. Right? So, and what it essentially means is that you have to have a right input, whatever input you have, the right one, the amount, in the right amount, you have to put at the right places. Hello? May I know who's speaking? From where? Okay, sorry. There was some. Okay, so so it is the right input, right amount, right time, right place, and right technology. So it's a combination of all these things. In India, precision farming implies micro irrigation technique, as I mentioned, drip irrigation, and site-specific nutrient management. Okay, it's an improvement definitely. When it comes to drip irrigation is the most efficient method of applying water, right? But for it to take care of spatial variability, you need to have sensors. You need to have sensors at different spots, so it becomes very expensive. So you have to work out for some simpler solutions. So, so as I said, it really implies when I say drip irrigation is the most, or drip irrigation, it gives the most efficient way of applying. But in reality, when we talk of precision agriculture, it implies delivery of all inputs, not only fertilizer, but also water, herbicides, pesticides, are as per the actual site requirement. Let me give one example. If you go to a field and find there is some pest attack, the pest attack will not be in the entire field, it starts somewhere in between the patch. So if you can take care of that patch, then itself, it will take care of, you will reduce the usage of that pesticides or herbicides a lot compared to spraying the entire field. That is being done right now. But it also means that this is a very advanced technology. It requires a seamless merging of multi-source data, whether it's remote sensing, GIS, GPS, sensor of various kinds, a lot of analytical techniques. So it has to be done by a trained technician. That is the message I want to give. Okay. Now, this is just to show you that earlier when we started the precision farming, it was satellites only, which was using sensors and aeroplanes. Now drones have come into the picture. Now, these drones can carry all these sensors which I mentioned here, which satellites or aeroplanes could take. So, all those drones are available now, and they can be linked with the sensors. They could be for nutrient, could be for pH, EC, or anything else. Sensors are available, right? And all these can now, therefore, be used for weed detection, they can be used for pathogen detection, yield prediction, stress, whether it is water or nutrient, all this can be done. So it's possible now. And the advantage with drones is that you can take care of the individual farmers' fields. A drone is something which is you can carry a satellite in your hand. These are some examples. You have heard that mostly it is being used for spraying nano urea or pesticides. This is one example of a variable rate applicator in operation. So, as I said, because of the variation in the field, you need a machinery which will deliver the fertilizer or whatever it is required, depending on the site requirement. So, we have this machine which is working in Punjab. So now people are realizing, and these things are available. This just to show you a drone is there, and these are our experimental fields. Experimental means maybe 4 by 5 meters or 6 by 4 meters or something like that. It is possible for the water stress to be captured by this drone in individual plots. Means maybe 25 square meters or something. The point I'm trying to make is that It can be easily done for the farmers' fields in India, which may be the smallest size. For example, in Bihar, we know even 1 acre means farmer will be having 2 or 3 parcels. Okay. Now, this can also be done for nutrient management. So this, again, experimental fields through this drone, it's possible to have a plant nitrogen content. And then once you have the plant nitrogen content and the status of the crop, we can always suggest, okay, this is the fertilizer requirement of nitrogen. So by showing these plots is that this variability of this type can be captured by a drone. Okay. These are, of course, drones. I would like to say that, I mean, these are all there: crop health monitoring, fertilizer, pesticide, livestock, geofencing. So many things drones can be used. In addition to the pesticide and narrow applications, there are so many advantages. Uh, One is security, you have it with you, high efficiency, frequency is up to you, very fine resolution, it's few centimeters also you can monitor, and low cost and easy to maintain. But then there are connectivity issues. We need internet connected, because that's connected to your mobile or to your whatever it is there. It is weather dependent because you have very small unit, and then the strong winds or something they can affect when you're trying to spray either nano urea or pesticide. So this is required, and then of course it requires all those knowledge skills to make it operational, because you want to use all those sensors, you need to be very skilled at it. It's okay. These are just some to highlight these, that even for crop insurance it can be very handy, because I have seen when there's a hailstorm, a farmer has got his crop totally destroyed, but the adjacent farmer's field is intact. So to quantify and assess those conditions, drone can be very, very useful. So these are all various advantages. A lot of advantages can be there. And when we shift on to uh, integrated cropping system, actually we need a lot of data. When we talk of AI, we talk of ML, we talk of IoT, but you need a lot of data to quantify the behavior of these animals, whether it is pigs or chicken or cattle or goats. Even in aquaculture, it's possible to have underwater cameras. But then you need all this data of huge data, quality data. Only then you can use these techniques. And then you need a service provider who will integrate all this analysis and give advice to the farmer. It is being done in some cases, for example, pesticides and all these things, nano urine, all that, they're doing it. But I would say it at a very basic level. We need all, because we don't have that much information with us to really make this functional. Now, there is a lot of talk about why nature-based solutions. Why we should be sticking to nature-based solutions. One is a nature-based solution means there's synergy in between the ecological and integrity and the food production. So we're trying to have a win-win situation. Benefits are several. You can have improved water sufficiency, biodiversity, soil health, reduce emissions, and also develop long-term resilience. And this is important because we have to align whatever we do with the sustainable global goal, that is sustainable intensification and climate adaptation, what the purpose of SDGs is. So I'm just giving about soil physical health. Why I have taken up soil physical health is that the soil health card currently only takes care of the nutrient part, the chemical properties. But there are soil physical properties which are very important and which affect the performance of growth. And for example, structure, porosity, bulk density, infiltration rate, aggregate stability, which shows how the soil is going to be there, and how water moves, how which plant species. So all these are linked with the soil physical properties. Erosion is very important. I mentioned about sediment generation, which causes your silting in the reservoirs. So all these things that is why, in addition to the soil chemical properties, some of these earlier the texture was routinely measured, infiltration was also measured, bulk density was measured, porosity was measured, but probably there's need to go on for aggregate stability so that you can get the benefit. These are some examples. They will be circulating. I will not go into details, but there are already projects which have shown the advantage of these, that you are able to improve the environment of the soil, the environment itself, above the soil and also not affect the productivity. So all these things are there, already documented. So these are the options which are available, in which the nature, they are all nature friendly. So these are some of the properties which I mentioned, which were there. For example, these are the problems and these are the solutions. So all these show that these landform specific intentions work best, when it comes to erosion, for example, contour trenches, bunding, vegetative barriers. And as I told you that soil erosion is one of the key factors which we are neglecting. We have to restore the soils, but as I showed you, the degradation has increased. Okay, plant root systems are powerful physical engineers, so that is why agroforestry, deep-rooted grasses, deep-rooted cover crops, grasses, they all help in binding the soil, increasing macropores, and stabilizing aggregates. We all know about water harvesting. In fact, uh, rainwater, we really allow a lot of rainwater to go as such to the sea. So there's a lot of scope. Only 30% we are utilizing. So there's a lot of scope for water harvesting. And as I told you, we have, even when all our irrigation water resources are there, probably 40% of our area would be rain-fed. So water harvesting is required. Controlled grazing and commitment are also very important, because you've heard about June. The period of cycles is reduced. So all these affect the environment. And then, of course, organic inputs are there. As I said, increase in carbon, organic carbon is a clear-cut indicator that your soil is in better condition. Okay, so this is just to highlight that the soil properties, physical properties are also important in addition to chemical properties, and it has many cascading effects in terms of better nutrition, biological activity, higher yields, and of course climate resilience. Because even if the soil is able to retain more water, it will help us in going through a drought period. Then, of course, as I said, afforestation, contouring, agroforestry, they have to be tailored to the soil physical conditions, and they also have a lot of benefit. So, if I have to now towards the end, what is the way forward? So, we have to have effective soil care for its soil health, productivity, and ecological functions. Soil testing and assessment, I already told you that the government is doing a lot for this, and we have also talked to the ministry that please ensure that you have qualitative data collected through soil testing and let it geo-referenced, so that you can easily utilize the information for having a large-scale area. Soil conservation practices, erosion control, cover cropping, balanced fertilization is very, very important, because even today our focus is more on the nitrogen, phosphorus, potash. We forget the rest, which is important. Crop rotation can help in improving the soil nutrient balance, also reduce the pest and disease pressure. So these are those nature-friendly options which can help you. Water management, we all know that water is very important. It is the elixir of life, and and it's one resource which is finite. Finite means non-renewable. So whatever water we had million years ago, the same water is available there. What we have done is probably we have uh, degraded its water quality through our lifestyle, whatever. I mentioned about rainwater harvesting, organic matter, soil structure I mentioned because of soil physical properties. We are going to minimize heavy machineries. How do we minimize that effect? Because when you go for minimum tillage, you need machines which can, do the sowing in those soils which have not been tilled compared to theirs. So all these things are there. Okay. The important thing is that we have to increase focus on the biodiversity. One of the problems why the strong feeling against chemical fertilizer is that they do not encourage microbial, or they affect the beneficial organism. Yes, that's true, because in Indian conditions, the organic carbon of soil is less. Earthworms don't have something to feed upon. That's why when you add organic matter, they multiply, and then they are able to mineralize those nutrients which are available. And they also take care of many beneficial products, organic products, which help plant to tolerate a little bit of stress. And these are there. As I already mentioned, we are focusing, trying to reduce the chemical inputs, because one of the main reasons that it is very the efficiencies are so low and the waste is so high, and that is one which is being which is brings a bad name to that. Otherwise, if you can use them efficiently, the inputs are required. You cannot produce more without the right inputs, And of course, this waste management, of course, I have not talked a lot, but a lot of waste waters, municipal waste is being dumped on the soil, which affects the quality. So we are supposed to be very important about these things. We are carrying out a lot of education awareness programs. We try to introduce community engagement so that more people are involved. Because if many of the farmers are at one time there together, probably that is better. The response is better. Okay, and policy, as I mentioned, government is trying. They have come up with so many policies and trying to reduce the chemical fertilizers, giving farmers. I said, Pranam means you can, if you save one fertilizer, some 50% goes to the farmers who have adopted this. The government has come up with now a proper carbon credits is there. There's an agency, Grow Indigo, which is focusing on rice wheat area, where they're going to give carbon credits. They have given, in fact, I was told that in January, the first installment, a 3-year basis was given, and the amount varied from 15,000 to 45,000. Those who adopted the best management practices. So there is. The government has also introduced green credits. The carbon credits was focusing only on the removal of carbon dioxide. 1 ton, you get one carbon credit. Green credits, if you can improve if you use any management that improves the efficiency of the resources, you'll be able to get one green credit. This can be converted into carbon credit and finally into terms of rupees. So this is going on. So what is the take-home message? Because of caring for soil, I mentioned 3 particular things. We cannot manage what we do not measure, right? We all know. For management, we don't need to know how to manage it. We cannot sustain what we do not monitor. Obviously, if you're not going to monitor, how will you know what is happening, what is not happening? So we cannot care for soils without integrating both into management. Measure, monitor, and management, they have to go together. So the conceptual framework for caring for soils is measure, monitor, and manage. Measure, monitor, manage. Soil is a living dynamic system. It requires, the soil care requires evidence, continuity, and action. That means the 3M framework links, this 3M is measure, monitor, manage to diagnosis, dynamics, and decisions. Soil management without measurement is guesswork. I think we all know that. These are just ecosystem services. We generally, when we talk of ecosystem, there are 4 components: provisioning, culture, regulatory, and supporting. Our focus is generally on provisioning. That is what increases the yield. But there are the regulatory and supporting services are also important because they are the ones which are helping sustaining the productivity. So if you neglect them, if you neglect these services, then you are going to probably have a lot of problems later on. Okay, so these are some of the benefits. Why we have been talking about payment for ecosystem services. Green credits, carbon credits, green credits in particular, are trying to, giving you farmers some benefit if you are able to work and improve the system. So these are some of the services which are available from soil. If you take care of soil, you help in water regulation, water quality control, erosion control. You cycle the nutrients, they took care of the biodiversity, and probably help in sequestering carbon, reducing all these things. So these things go together. And this slide I like to show because it is really true that man, despite his artistic potentials, his sophistication, and his many accomplishments, owes his existence to a 6-inch layer of topsoil and the fact that it rains. That means both soil and water are important. WHO, when the One Health concept was started, it was basically plant, animal, human health, right? Uh, it was and more focus on the diseases part, from animals to humans and all that. But now, according to the World Health Organization, One Health is an integrated, unifying approach to balance and optimize the health of people, animals, and the environment. Right? So that becomes important, and soil is the starting point. And of course, it is important to prevent, predict, detect, and respond to global health threats such as COVID-19. This was how One Health has now, government has also started One Health. One Health approach is particularly relevant for food and water safety, nutrition, the control of zoonosis, pollution management, and combating antimicrobial resistance. So these are the issues, and soil plays a very critical role. And Sir Albert Howard, he's a British scientist. He came to India, and he wrote a book, The Agriculture Testament, and this is what he said in 1940, that the health of soil, plant, animal, and man is one and indivisible, and soil is the starting point, and that is why caring for soil is very, very important. So for human race to survive, we have to keep soil alive. I think with this I end my talk. Thank you very much for a very uh, patient hearing. I'm sorry for all those technical hitches that we started late, but now it is open for questions.
Thank you, sir. Thank you so much for your informative presentation. Now let's move on with the query session. Dear participants, please drop your questions in the chat box. We will address it. Okay, sir. The first question is from Anjali Shukla. The question is, can soil truly be managed, or are we only managing plant nutrition while ignoring soil as a self-regulating ecosystem? Is soil degradation primarily a chemical problem or fundamentally a biological collapse?
See, when I mentioned when we talk of soil health, actually, I mentioned that the soil health card takes care of only the chemical part, the nutrient part. But the soil physical properties are also equally important, and also the soil biological properties, the microbial. And that is why we are now focusing a lot. Why we talk of organic farming or natural farming is there the focus is in trying to increase the microbial activity. In fact, if you have more microbes, as I mentioned that, for example, earthworm activity, fungi, bacteria, if the population increases, it is said that the soil is healthier. So it is all three which are important. It is easy to manage fertilizers because okay, nitrogen is efficient to bring urea into it. But for other properties, you have to put in more efforts, right? So that is why it is there. But they are all important, and if you want the system to be sustainable, you have to take care of all these three. And we are trying to bring this part into the soil health, that you should take care of the biological part. The problem is that for physical properties, also it is easy to measure, but for biological properties, you have to probably take the sample and do the analysis immediately. But soil organic carbon and the health can give an indication of the biological health also. So that is one reason why, but they all three are important.
The next question is from Rohit MP, MSc Agri Agronomy student, University of Agricultural Science, Dharwad. His question is the nano fertilizer best substitute for chemical fertilizers like DAP, urea, future nutrient management? As an agronomist, which area is best to do research for future?
Okay. Now, when it comes to nano fertilizer application, see, first thing is that for a fertilizer like nitrogen, for example, it is required in large, right? And when you apply nano fertilizer, whether it's urea or DAP, the plant growth has to be adequate. Otherwise, if I spray nano urea in the initial stages, it will fall on the soil. It will not be taken on the plant. So it's a combination of both, an ideal combination on which now people have worked out that, for example, for nitrogen or phosphorus, this is the amount that you must apply on a basal level, and the rest can be done by spraying. Micronutrients, because they are required in small quantities, you can always do it through spraying, foliar spray. But for major nutrients, because they are required in larger quantities, and then the demand depends upon the growth of the plant, and that varies. Banana would be different, wheat would be different, so you can tailor make those. But for major nutrients, you have to have a combination of both, some basal application in the soil and some spray, because no point in spraying if the vegetative stage is not there. You need proper foliage so that whatever you spray can be taken up by the plant. So that is one reason. You need to work on that, because as I said, if you really identify, a plant physiologist would know that the requirement of a plant for a nutrient varies with the stage. It doesn't mean that it requires nitrogen or phosphorus, potash at the same time. or require iron at the same time, or zinc. It requires. With spray, you can tailor make your, and that is why I gave example of fertigation, that when in fertigation, you can deliver the nutrients as is required by the plant. So that is the advantage. So that scope is there for working as research. Yes. Thank you.
Thank you, sir.
Yeah.
The next question is from Akshat Jain, student of JNKVB, Jabalpur. His question is, sir, how can we make the lab-to-land technology accessible to farmers so that they can earn profits?
See, we have been, as a student, you must be knowing that we have more than 700 KVKs, in the country, in the district. And each, at least one in each district and larger districts too. So they are the ones who take. Now we also say that, for example, we are encouraging small and minor farmers to follow integrated farming systems, having a combination of crops, livestock, agroforestry. The reason is it gives resilience. If something happens, one component may not be so productive, but the other is. So we link now all the systems with the income. So we tell the farmers, why you do this, your income. Earlier we used to say, okay, but nobody is interested in just the yield, because you may get yield, higher, but the market may not give you so much price. So it has to be linked with the income. And we now try to do it in most of our recommendations. And that is why I said now, when we talk of water, you would take of water productivity, which is how much benefit that water efficiency would do in terms of rupees. Same thing is for nutrients also. So we are trying to do all this, and obviously, whether it's farmer, anybody, ultimately they are interested in their income. So that is why in most of the slides I mentioned, livelihoods are very important. The income was farmer also, and one of the reasons why we recommend integrated farming systems for small and marginal farmers is that, in addition to resilience, through integrated farming system, you can get some income. Every month, like, you get salary. Otherwise, if you grow rice or wheat, you have only get some product at the end of the season. So this is why the additional components are giving that benefit and increase the income. So we tie up everything now with the income.
Thank you, sir. The next question is from Vivek Sarkar. His question is, it's good to, okay. How many organizations in India are doing the carbon credit businesses, and how many of them are actually reducing the GHG emissions?
See, in fact, there were a lot of many. I cannot give you the entire list of who are talking of carbon trading, right? Only recently now, Grow Indico is one which is doing for rice wheat system in Haryana, Punjab, and UP. They're trying to improve that. Earlier, it was easy in case of agroforestry, afforestation, because you know the tree, you know how much will grow over it, so they were there and they were doing it. But now only it has started involving the farmers. And as I said, Grow Indigo is one which has paid some, carbon credits, money earned through that. Earlier, what was happening was that you do something and you earn carbon credits, so they were able to offset. Farmer was not giving much of benefit. But now they have started, and there are several companies. Grow Indigo is one which is there. There are many big companies who are doing it. I think ITC is also doing it. And many of those afforestation are being done by the government also. Uttarakhand, I know, has given for afforestation, for agroforestry. So some governments are also doing it. Some private agencies have now started, because this scheme of green credits and carbon was officially launched in 2023. Earlier, only private industries were doing it. Government agencies were not involved. But its information is available on the internet, how many agencies are there. But this is the latest one which I showed, Grow Indigo, which has really taken up on a larger scale. Afforestation is going on since quite some time.
Thank you, sir. The next question is from Ashutosh Gaurish from National Institute of Food Technology. His question is, what role can food processing industries like those NIFTM students play in improving soil sustainability? Can waste valorization significantly reduce soil degradation?
See, for soil degradation, as I have mentioning, uh, it is essentially the management, right? And sustainable management has, I said, we talk of soil health now, you know. So how you produce, you know, so must have the best management practices, whatever you're doing, and that will increase it will sustain the productivity of whatever you are producing. For each, we have the best management practices are there, which can help in increasing the soil carbon or soil organic carbon, sequestering carbon, and that is why how they can sustain the even for processing. There are ways, because processing also involves, the energy, it also involves water. So there are ways and means in which we can reduce at different levels, and industries we are recommending to go in for water editing so that they reduce the amount of water which is being used, right? Yeah.
Okay, thank you, sir. Sir, we are getting more questions. Can we continue with query session?
Yeah, sure. Next
Okay,
few.
sir. Thank you. So the next question is from Avanish Babshir. Sir, as you said, we have to improve our resources, that is soil, by 2030. But as per our budget 2026 for agriculture, majority of the budget amount is given for chemical fertilizer and every less is promoted for organic. Why is it so? Even after knowing the ill effects since back then, are they having their own interest in it? Like the benefits from the such companies producing these chemicals with collaboration of foreign companies.
See, this is it's not. Oh no, it's not like that. See, the thing is, India, as I have mentioned about food security, right? We have to provide food for all, right? As per the all below poverty. That is when it is by law, it is legal. It's a legal right. If I'm poor, I have to be provided by food by the government, right? Now, that is number one. Number two, government wants to reduce the chemical fertilizer use. It's no doubt about it. They have a program on natural farming. They have a program on organic farming, right? And they have now started giving, as I said, in incentives now. When I said green credits, I said if you can reduce or use more efficiently the resources, you will get some benefit, right? These are all ways, and you can't. The other thing is that if you want to replace the chemical fertilizers, okay, where will you get those organic fertilizers, or right? So it is not possible for the system to change overnight. So it will take time. Right now, as per the data, whatever the amount of nutrients are being removed from the soil, the balance is negative. So if we take all our organic sources, crop residue, all that, maybe we will be able to bridge that gap. Understand? So it is not possible overnight that you can replace all chemical. Government is trying. Nano urea is more efficient. Neem coated urea is more efficient compared to other. That is why, as I mentioned, but farmers will, so they reduce the capacity of the bag from 50 to 45, so that they are using 5 kg urea less, isn't it? So these are the ways in which they are going to increase. And when we promote integrated farming system, government is pushing a lot. That is basically that we are going to reduce the external inputs which farmer has to pay. So these are all ways, and government is pushing for natural farming. They have allocated money. As I said, we have enough current technologies with us, whether it is soil, whether it is water or anything, that we can increase our productivity. Because if you look at the technologies, we are producing, one, two, we are in the first, second, third rank in almost all the commodities. But if you look at the productivity, that is yield, production per unit area, we are still not in the first 10 globally, okay? Which means that we can still produce more from the technologies that are available with us right now, okay? And as I said, one of the reasons why efficiency is not there, because the prices are so cheap that nobody is concerned. Why we don't use water efficiently? Those farmers, because water is almost free. There's hardly any charge for water. That's why we are not bothered about the efficiency, which happens with everybody. And that is the reason why these things are happening. Yes, government should have given more money, I agree. because problems are going to come up maybe 4 years, 5 years, 6 years later. But we have to start working on them right now. Yeah.
Thank you, sir. The next question is from Harleen. Her question is, how essential is micronutrient soil testing, and do our farmers have access to this facility?
See, there are 17 elements which are required, for getting the maximum yield, right? So, and if any of these are deficient, the productivity is affected, right? And these soil health cards now are looking at the micronutrients also, in addition to nitrogen, phosphorus, potash. And they are available. Only thing is, the mentality is of, NPK, NPK is more important, NPK is more important. If the farmer feels his rice or his crop is looking sick or something, he'll add more of these NPKs without going into that. So that is important. And they are available. It's not they're not available. All those micronutrients, they are available for anybody who wants to use it. So, because we know, and it's not only the soil, plant, it is also we are eating plants or animals that feed on plants. So all those micronutrient deficiencies which happen in soil are also transmitted to us. And we have a livestock, many of our diseases are linked to remember zinc in COVID? Yes, you remember zinc, that you should take zinc was given. That was a micronutrient for our own, so build immunity. Vitamin C, again something. So all these are there. So like that, you have all these elements which are important. Micronutrients are important and they are available.
Thank you, sir. The next question is from Manoj from the University of Agricultural Sciences, Bangalore. This question is, can we use seawater which is desalined and input of basic minerals and plenty of organic matter to it, so it can be used in agricultural field?
What do you think? Seaweed?
Seawater, sir.
Seawater or seaweed? Seawater you cannot use, it's very saline.
Yes, sir. He is asking like, can we use it after desalined and by adding basic minerals and organic matter to it?
Okay. Now, see, what he is asking is about seawater. Seawater is highly saline. It is very expensive to desalinize water for agriculture. Okay. Even for drinking, if you use desalinized, it is very expensive. But for potable water, we will able to. But for example, you know, how much you can just calculate that you require. When Chennai was importing 10 million liters of water every day for drinking, a few years back, I think many must be knowing that it used to come by train. Now, if a 25 hectare field of rice with 5 standing water would be that much water. Okay, and you can calculate it. Let me give you very simple terms. If you save 1 centimeter of water per hectare, okay, for agriculture purposes, it will provide you with 275 liters per day. 1 centimeter of water per hectare. And 275 liter means for a rural family, it is 55 liters per person. That means a family of 5. In a city, it is 135. That means 2 persons. Water requirement can be taken care of by that 1 centimeter of water. So, but the quantum is so high that you cannot do that in economic terms. You're getting my point? For agriculture. Drinking also is not possible, but nuclear techniques are being used, convert. Even then, it's not so cheap. So that is why thinking of seawater for, purifying it for agriculture, even wastewaters which are there, in cities, they need to be treated, but they can be treated for irrigation, not for drinking water. But because the volumes of water that are required in agriculture, I gave one example how much it is. So 10 million liters means 25 hectare field with 5 centimeter of water. So you can imagine, if you have to do it for it's not possible. Theoretically, yes, but cost would be impossible. It will be very, very expensive. For drinking, yes, that also will be expensive, but certainly not for agriculture. Seawater. Seaweeds are being used. Seaweeds are there being used as fertilizer also. Seaweed feeding fodder to livestock reduces the methane emission. That is there. That is being worked upon. And they are available also. Okay.
Thank you, sir. The next question is from Somappa. His question is, what policy changes are needed to reduce soil degradation in intensively cultivated regions like Punjab and Haryana?
See, one is to what we say is that if you can replace 25% of the chemical fertilizers through any organic source, right? Um, um, Compost, FIM, biofertilizer, anything. If you can reduce 25%, right, that can help. You can, we say rice, wheat, include the moon crop in between summer, any legume which can increase soil fertility. Use water less because in areas, that's why they are saying go in for tri-seeded rice so that the water consumption will reduce. So all these things are there which will help in that. So there are many options. That is, and I gave an example. The Grow Indigo is giving benefits to Punjab, Haryana, UP farmers to switch over to direct seeded rice, right? Use minimum tillage. They are providing all those support so that the environment friendly. It is there. It's possible. Yeah.
Thank you, sir. The next question is from Chaitanya. As we saw in the PPT that urea supergranules increases 20% yield in maize, is USG cost effective than regular urea? And another question is, drones are basically being used for spraying fertilizers, but do drones really impact farming in other factors too?
See, right now, drones have a huge potential. Let me say it very clearly. Because all those sensors which I showed there can be used by a drone to monitor everything. There are drones available which can also spray pesticides in a variable. For example, they will spray only where the disease is there. Those drones are available, right? And the thing is, it started with spraying, of pesticide, that you need something which can do it quickly and all that. That advantage is there. But there are many more advantages. But you need some skilled person, to do it. A farmer can spray it because they give a software with that package, So he says, okay, this pesticide, he puts in the drone and that does it. But it has a lot of scope. Some of these companies are using for geofencing because a farmer's field is there. He may not have a bund, but you can have, okay, this is the farmer's field. So you can use these. So that scope is there. Lot of scope is there. Right now, as I said, it is being used basically for spraying fertilizer and pesticides. Even that, as I mentioned, in a field, when it's, a disease comes or a pest attack is there, it's not on the entire field. It starts from some patch somewhere. And through drones, it's possible to identify that patch, right at the very beginning. And there are drones available which will spray only that part. You're getting my point? So when they pass over that spot, they will spray the pesticides or whatever is required or a nutrient at that spot and ignore and leave the rest part. So these variable rate adapted drones are available in the country. Okay. But it's not being used so much, but they should be used. Potential is there. But then you need some technical person to handle those drains. Farmer will not be able to use those drains. This is my point.
Okay, sir. Thank you. The next question is from Abrar Khan. His question is that what are the most practical and affordable methods to improve degraded soil, and how can we measure whether the soil is actually recovering?
See, methods are very simple if you can have vegetation, crop cover, If you have vegetative cover over any spot, that helps, because not only that, when rain comes, see, erosion occurs because the rain comes. So they're able to buffer it. That is one simple thing. And the second thing is the structure. As I mentioned, we are not bothered much about the structure, but the structure is the one which causes all that. The poor structure means more erosion. So you have ways of monitoring what is the micro aggregates. They call it mean weight diameter. I mean, there's so many terms. So they also are linked directly with the capability. So if you measure those, you can see increase in soil organic carbon, increase in mean weight diameter. All these are parameters to show whether soil is recovering or not. Growing vegetation helps in preventing, plus root binding. If you have pastures, why I was mentioning pastures, they bind the roots, bind the soil together, the roots, and they are able to tolerate those erosion. These are ways, the many ways. Agroforestry, grow trees along with that. All these are measures which will improve reduce the degradation. I mentioned a lot in that where I said nature-based solutions, they are there. How to take care of this. They are given a lot to make vegetative barriers, contour bending, terracing, all those things are there which help in reducing the degradation.
Okay, sir. Sir, can we ask last two more questions?
Okay. Last question or how many?
Yes, so many questions, sir. So we are trying to wind up. Okay. Sir, the question is from Akshay Kumar. He's asking, sir, recently my father used doctor soil for chrysanthemum, but plants were dying day by day. My father used recommended dosages, but still facing same problem. Do you have any suggestions?
No, I would say that let him get the soil analyzed, Okay. There could be something else which is other than those nutrients which he's applying, which is causing this problem. Many of those, what we have those pots when you grow in our houses, terrace or something, this problem is there. But he needs to get the soil analyzed. There could be a toxic element, for all you know, from where they got the soil, which was being there. So sometimes these things happen, but often I cannot say if the plant is dying means something is wrong with the soil. Either I hope there not too much of water is being applied because sometimes, we always add more water, which is sometimes causes the problem. But otherwise, the soil analysis will give an idea whether there's a toxicity or there is a deficiency which is causing that or some soil-borne diseases there, which is not letting the plant grow. But often I cannot say anything like that. Yeah.
Okay, sir. Thank you. So the last question from Kushi Nayak. His question is that he suggests that farmers adopt natural farming practices to improve soil health, but the initial yield may decrease in the first few years. How can we motivate and support farmers to adopt these techniques?
Yeah. See, this happens in organic farming also. The government had a scheme on organic farming. So they agreed that first 3 years they would give some support, right? So that it can be compensated by that. That was there earlier. But now, as I mentioned, they have a scheme of green credits. So if you improve all these properties, as I said, Grow Indigo has done, but after 3 years, they were able to compensate. So it is possible. Yes, initially there is going to be some decrease because all the nutrients are not released. But government is giving some now incentives for that. Hopefully, the green credit scheme was only started in 2023, but now they have come up with some mechanism. I know for trees it's very easy, so they can do it. For the increase in carbon, soil organic carbon also they have quantified, and Grow Indigo is done. They have given details of how, and whatever is there, the 75% of the share goes to the farmer. So the farmer is getting a benefit through these things. And natural farming also, in that scheme, they are giving some incentive to the farmer to compensate for those, reduction in yield for the initial 2-3 years. There.
Okay, thank you, sir. And thank you all the participants for your thoughtful questions. And again, my sincere thanks to Dr. Anil sir for addressing them so clearly. Now, I would like to invite Ajay Kasana sir to share a few words with our participants. Sir, please.
Thank you, Musina. Thank you very much.
Jai Hind,
Pleasure.
thank you so much, Dr. Sahab, for your blessings and presence today.
I'm sorry that there were some hiccups in the beginning. I don't know why it is happening.
No issues, Dr. Sahab. In the online sessions,
No,
this is the process.
I will check up what is the problem. I mean, why it
Yes.
happened, because Maybe the
Yes,
version that I have here is a bit older, you know. Anyway,
yes, Dr.
so thank you very
Despite,
much for your very patient hearing. It took some
thank
time.
you, sir. Thank you so much, Dr. Despite having technical issues, you have delivered a very in-depth and detailed session that was really insightful and helpful for the participant. There are lot many questions they have in their heads. Definitely, it is going to be intriguing and brainstorming session. So thank you so much, Daxa, for your
Yeah.
blessings
Yeah, you
to our
can ask
audience.
them to, can give my email, they can ask me questions in case. And I'm
Definitely,
always
Daxa.
available, right? Yeah.
Sure. We have provided them feedback per forma, and whatever the questions we are going to get, we will
Yeah.
forward and we
Oh,
will answer them
okay.
in the meantime. So thank you so much, Daxa,
Thank
and
you very
thank you
much.
to all
So,
the participants.
okay. I
Jai
can
Hind.
leave now?
Yes, please, Musina, please conclude.
Yes. Thank you very much. Thank you very much.
Okay, thank you, sir. On
Thank
behalf of
you.
the Agri SAARTHI team, I express my sincere gratitude to Dr. Anil Kumar Singh, sir, for today's informative and research-oriented session on caring for soils. Sir's insight have added strong academic and practical value to this program. I would also like to thank Ajay Kasana, sir, our organizing director and chief secretary of Agri SAARTHI, for his continued guidance and efforts in ensuring the smooth conduct of this training initiative. My thanks to Dr. Vijay Kumari for her coordination and support throughout today's session, and to all the participants for your active involvement. I also extend my appreciation to entire Agri SAARTHI team, whose consistent behind the scene efforts make each session possible. Thank you all for being part of day 6 of Agri SAARTHI KRANTI 2026. We look forward to your participation in the upcoming sessions also. Have a pleasant evening. Jai Hind. Thank you.